Okay, this video is about demonstration of slope fields and how we can use them to gain a value of y when you can't anti-differentiate. Okay, so what I've got here is I've been given the derivative and it's dy dx equals minus 2x plus y. So I know information about the differential equation. I know that when x equaled 1, y equaled 1. I want to estimate what y equals when x equals 2, but I can't solve the equation because I can't anti-differentiate this. So what I'd like to do is I'd like to create a slope field. So at the point 0, 0, dy dx will equal minus 0 plus 0, it's going to equal 0. So the gradient's going to go in that direction at x equals 0. At the point 0, 1, dy dx is going to be negative 2 times 0 plus 1, going to equal 1. So it's going to look like that, have a gradient of 1. At the point 1 and 1, dy dx is going to equal minus 2 times 1 plus 1 is minus 1. At the point 1, 0, dy dx is going to be minus 2 times 1 plus 0, negative 2. At the point 2, 0, dy dx is going to equal negative 2 times 2, negative 4 plus nothing, negative 4. Steeper. At the point 2, 1, dy dx is going to equal negative 2 times 2 is negative 4 plus 1, negative 3. Now I continue that by working out all of the gradients at all of the points. At 1, negative 1, I've got negative 2 times 1 minus 1 gives negative 3. These are really steep positive, these are steep negative, and we have running across here my zeros. And we're moving from positive gradients over here to negative gradients. Okay, so I know that 1, 1 is a point that is on the curve. So I suspect that it's going to have a negative gradient and have a 0 there. Then it's going to be controlled by those gradients like that. And we're going to go down here and be controlled by those gradients. So I'll be thinking my prediction for x equals 2 is something like around about y equals, I'm for negative 2 to negative 1.5. I'm going to say negative 2.2 is my prediction for y when x equals 2. What's it going to look like on my graphing calculator? Well, I've got my slope fields here, and I'm going to do minus 2x plus y. I've graphed it, and that sort of shape is very similar to what the graph was suggesting. And I've got my initial condition of 1, 1, which is here. And when it's drawing for 2, its prediction for 2 is around about 1.9 or negative 1.9 or negative 2, which is very similar to what my prediction is. So we didn't solve the differential equation, but what we did is we worked out what the gradients of a curve would look like on y, and I sketched in an estimate for what y might look like. And of course, it's going to change depending upon the initial condition. So for example, if that was at negative 1 and 1, then my curve is a totally different curve because it's not going to get anywhere near the 0 to then bring it down again.